this video will help you with domain and range. So we're going to look at domain and range for our roots, mostly our square roots, but the how we handle the domain and range for square roots is the same graphically for all roots. And square roots, fourth roots, sixth roots, eighth roots, they would all be handled the same as a square root would. And then cube roots, fifth roots, seventh roots, ninth roots would all be handled similarly. So the first thing we're going to do is look at it graphically. So when we talk about domain and range, domain talks about the x's. It talks about how the graph exists horizontally, so left and right. So horizontally is how does the graph exist left and right. Range talks about the y, the set of all y's that we could expect for a function. Talks about up and down vertically. So we're going to look at a couple of examples here. And this is our first one that we're going to look at right here. So this is example number 1. If I were to graph something and I needed to identify the domain and range. So what I'm going to do, if I'm thinking about how does it perform horizontally, so I'm talking about the domain. So for what values of x, so we do a curly brace because it's a set of all x's that work for the function, a set of all x's such that, our line means such that, basically a rule. So it's a set of all x's, that's the curly brace, that follow this rule. So if we look at when x is equal to -3, there is no graph whatsoever. Even if I extend this out, it's only going to extend to the right. So it would be undefined. It wouldn't exist for x is equal to -3. It wouldn't exist for x is equal to -2. It's still no graph. It does exist for x is equal to -1. We know it's -1 and 3. I could find one for 0. I could find one for 100 because this is extending out. So what I know is here is the line that it does not cross horizontally. So I know x needs to be greater than or equal to -1. That would be my domain. So let's look at this graph and let's think about the domain. So for the domain, I have x such that, what is the rule? Well, I don't see any values for x is equal to 1, x is equal to 0, x is equal to -5. The first time that I see a value on my graph going this direction, so no value, no value, no value, ding, 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 I have a value at 3. I can reach up and touch the graph at 4. I could go out to 100, I could go down and touch the graph. So I know that my x has to be greater than or equal to 3. Close the curly brace or the set. So let's think about this one. This is the cubed root function. For my domain, well, what do I know about my domain? -1, I could find a location. -50, I could find a location. +2, I could find the graph. +1,000,000, I could find the graph because it goes on forever in both directions. So the domain is all real. All real numbers. Let's take a look at this guy here. So our domain, I want you to pause the video and I want you to go ahead and answer this question and then push play. Okay, so for this one, it starts at -2. I can always find a value, so everything is bigger than -2, so it would be greater than or equal to -2. So that's how we look at it graphically. All right, so now let's look at the range. Range, when we look at it graphically, now we're looking at the vertical. Where do we start seeing values vertically? Well, in this case, vertically, so this was my domain line. And now if I think about it vertically, when y is equal to 1, y is equal to 2, still no graph. Y is equal to 3, ding, ding, ding. So this is my range. And I can find a value for y increasing. So it'd have to be y such that y is greater than or equal to 3. Now if we think about range for this one, well, where do we start seeing y values? No y value, no y value. Up right here, I start seeing a y value when y is 1. So I know, and I'm going to continue seeing y values. I can come over and touch my graph. So I know that y such that y is less than or equal to 1. It's going to be anything lower than 1. This guy, I have all values, so my range. So when we're talking about a cubed root, a fifth root, a seventh root, they all are going to perform in this manner. So it would be all real, all real. And our range. When we look at our range for this guy, where do we start seeing values? I see a value there, I see a value there, there, I see a value at -1, but I do not see anything less than -1, so y has to be greater than or equal to -1. So that's graphically, how we look at something graphically. Now let's look at algebraically. Well, we know the cubed root. If we have a cubed root, a fifth root, a seventh root, because I can take the cubed root of -1 and get -1, it doesn't give me an error, it's a real number. My domain and my range for these is all real numbers. Same thing with the range. So those are easy. Okay, now where we get into issues here is when you have a square root or you have a fourth root. So we could even add a little 4 here. I can't have a negative number come out of this radical. So when I'm looking at the equation, if I take the things that are underneath the radical, my domain, in this case, needs to be greater than or equal to 0. Or the stuff under the radicand needs to be greater than or equal to 0. So in this case, x has to be greater than or equal to 0. Otherwise, I'm going to get something that I can't have under that radical. Now, if I think of this one, again, here is my radical. Here is my radicand, the stuff underneath. I know that 3x minus 1 has to be greater than or equal to 0, because if it's not, if it's negative, it's not a real number. So I'm going to go ahead and solve. And so I know that x is greater than or equal to 1/3. So my domain would be x such that x is greater than or equal to 1/3. So that's how you look at it in the equations and get your domain. Anytime I see an even root, 2, 4, 6, 8, I have to have the stuff under the radical to be a positive greater than or equal to 0.